7b, we're going to look at confidence intervals for the mean, just like we did last time, but this time we have a small sample size. Okay, so in statistics, a small sample size is considered anything that is less than 30. Okay, so the process that we used in 7a, you have to have a sample size that is greater than 30. If not, it changes things a little bit. So you see some information here about something called a t-distribution. Okay, to make a long story short, what we were doing in 7a, the calculator was using a z-score to come up with that interval, to come up with that margin of error that it was adding and subtracting. Okay, but z-scores require sample sizes of at least 30, because when you have a smaller sample size, there's more chance for variation. There's more chance for it to be off from that true population mean that we're looking for. So when the sample size is less than 30, the calculator can't use z-scores anymore. They have to use something called a t-distribution. And the t-distribution basically is just flatter. So it ends up using a bigger number, and it makes our interval bigger. Because with that small sample size, we just have to make that interval a little bit bigger, because there's a higher chance that our sample could be a little off. Okay, so we have our calculator steps just like before. All right, we're still going to choose stat interval, but this time we're going to choose a t interval. Okay, and then here's the stuff we have to enter: confidence level, sample mean, sample standard deviation, and then sample size, just like we did before. All right, so we will look at an example. So we have a random sample of 20 cars, and the mean number of days it sits in there was 9.75 with a standard deviation of 2.39, and we want a 99% confidence interval. All right, so our confidence level is going to be 0.99. Okay, X bar is the sample mean, which in this case was 9.75. S sub X, that is the sample standard deviation. So for this problem, it was 2.39 days. All right, and then our sample size was 20 cars. So we grab our calculator and let's put in that information. So I'm going to go to stat. I want interval, so F4, and we need T because our sample size is less than 30, and it is a one sample test. And then I put F2 for it to go to variable, and now I'm going to put in my stuff. So my confidence interval is 0.99. My sample mean is 9.75. You see my symbol there looks a little different. Yours probably says this, SX. All right, and that is 2.39. And then our sample size is 20, and we hit enter, and the calculator gives us an interval. So 8.22 to 11.28. Okay, that is my confidence interval, and remember how we interpret these. So I am 99% confident that the true population mean is between 8.22 and 11.28 days. Okay, a sales rep tells you the car you were looking at was delivered 4 days ago, and he says you need to act fast and buy now because it will likely be gone tomorrow. Do you believe him? Why or why not? All right, so I would say no, I don't believe him because he uses this word likely, but the average number of days we know is somewhere between 8.22 and 11.28. Okay, so we still got 4 days to go before we get to that average. Now, remember, it's just an average. It doesn't mean that that car won't be gone tomorrow, okay? But it's not very likely. So it's possible, but it's not likely because that would be way less than the average number of days. All right, so now that we have these two different methods, we have Z and T distributions, how do you know which one to use? Okay, so here's this flow chart that you have to ask yourself. The first thing is the sample size. All right, if our sample size is greater than or equal to 30, then we can use a Z interval. So on your calculator, when you get here and press interval, we're using Z or T. Okay, so if it's greater than or equal to 30, we can use Z. All right, if not, we keep going through the questions. This is important. Is it normal or approximately normal? The question will tell you if the data is normal or approximately normally distributed. Okay. If we don't have this information, we can't assume that it's yes, and we can't use either interval. We don't have enough data to come up with a confidence interval. Okay, if the problem says yes, this is true, then do we know sigma? And sigma here is the the population standard deviation. Now this is very important, okay? Just taking a sample and the standard deviation of that sample, that is not sigma. That is that SX. Okay, so if you don't know this sigma, if the problem doesn't say either show this symbol or say population standard deviation, then you're going to use the T interval on your calculator. If you do know sigma, then even if the sample size is less than 30, you can use the Z interval, because knowing that population standard deviation means we can use the normal distribution. This is not really something that happens very often, because if we know the population standard deviation, then we would know the population mean. So this is kind of a weird case. I threw it on there, but it's not something that happens very often in the real world. All right, so we'll look at an example. We have 25 newly constructed houses, and then we have sample mean and population standard deviation. Which distribution should we use? Okay, so let's go through our chart. Is n greater than or equal to 30? No, it's 25. Okay, is it normal or approximately normal? All right, they say right here, assuming construction costs are normally distributed. So we answer yes to that. Is sigma, the population standard deviation, known? Okay, it says the population standard deviation, sigma, is 28,000. So yes, so we're going to use a Z interval here. Okay, again, that's that rare situation. Okay, and that is it for 7B.